Hi, my name is Dexter and from Group 18, and this is our Nokia Snake game. We are Andre, me, and Zainab. So I'll be going over brief descriptions of the .c files used for the project with a short demo at the end. So starting off in the Snake game main, this is where we check the body and border collisions to determine the game over state. And then this is also where we initialize all the peripherals and the snake and the fruit. It has a sysdig handler, which draws the current game state, and also has the port E and port F handler, which determines the directions of the snake. So the port E sets it left or right, while the port F sets it up or down. And then moving on to the next module is the snake module. This one has all the functions related to the snake. It controls the snake direction in the move snake. And then there's a growth mechanism in growth snake. Then also checks the body collision in this function. Then also makes sure that the head and that the tail follows the head in draw snake. And then moving on to the next module, we have the fruit module, which contains all the functions related to the fruit. It has the bitmap of the fruit, and also has the spawning mechanism, and then the check fruit collision, which checks whether the snake head collides with the fruit, and if it does, it will spawn it a new fruit at the random location. And then we have the ADC.C, and we use this to help make the initializations for the left and right push buttons found on the ADC simulation window. We also use this to debug those two buttons. And then lastly we have init.c, and this one contains all the initializations of our sysdig interrupt modules and port F and port E. Now time for the demo of our game. So starting the game, I'll move it up, move it right, and then once it hits the edge of the border, the game should end. The screen should clear. Hi, my name is Dexter Zamora from Group 18, and this will be a short demo of what was implemented in Release 2.0. Firstly, we implemented a way to change the rate of speed that the game will be carried out using values read from the ADC. The game speed can now be run from 1 times the base speed to 5 times the base speed. Here I'll show you a short demo where this is 1 times the base speed. I'll increase it to about 2.5 the base speed, and now here's 5 times the base speed. And then we also implemented and debugged a game over state, where the state was originally in the first release but had a bug where the text were not being shown, but after the bug was dealt with, the text can now be seen. And we also implemented a way to score the player throughout the whole game and display it at the end of the game. Thirdly, we implemented LEDs to certain command inputs. For example, you make the red LED turn on once the game over state has been reached, and the green LED is also turned on after eating a fruit. The green LED is required using timer interrupts to get the exact on time that the group wanted without it affecting the rest of the game. Show you that demo. Here's the demo, where once the snakehead reaches the fruit, it will trigger the green LED to turn on for a certain amount of time. And finally, Zainab took the lead for the PCB design of the shield, and we'll go over to her presentation.
My name is Zainab, and today I'll be going over the PCB component design of the Snake game. Looking at the schematic, we have a couple main components. We have the 4 push buttons that are active high. We have a reset switch, which is active low. A reset push button, which is active low. We have a slide potentiometer connected to the ADC to increase the speed of the game. We have our LCD screen here, and we have our headers used for to connect to the TIVA. Moving on to the PCB. In this view, you can see the underlying traces. We have our LCD and other components, which I'll go over a little bit in more detail in 3D view. So the LCD is here. These are the headers used to connect to the TIVA. These are the 4 push buttons. And these are the LED indicator lights and reset button and the ADC slider. Some comments to make on this design would be printing this out in physically to see how well this handheld design fairs, as well as implementing a different way of doing buttons, for example, similar to the Wii remote with the cross button system, which is a little more intuitive for gaming, as well as shrinking the design a bit more so it can be as small as possible. Thank you.